Good morning. My name is Chip Westerby. I'm the sales manager for Benchmark Measurement Solutions. We're formerly known as Turner Designs Hydrocarbon Instruments. Today's presentation is section 1 of a refinery utility water monitoring system. We're going to focus on the desalter and crude unit heating processes. Within a generic refinery, the heating and cooling processes are very complex. There might be up to multiple hundreds of different heat exchangers within a refinery. Some are steam processes heating up oil or fuel. Some are cooling processes reducing the temperature of those hydrocarbons. And in many cases, water from one unit is used to heat up or cool down hydrocarbons from a different unit. So these heat exchangers and the steam processes are going to be different in each location. In general, in the crude unit, the crude oil is heated up to between 250 and 350 degrees Fahrenheit before the desalter. After the desalter and before distillation, that crude oil is further heated to up to about 800 degrees, depending on the type of oil and the type of refinery and how the process is operated. If one of these heat exchangers were to leak, the fuel, distilled product, or crude oil could leak into the steam condensate process or the cooling water process. Depending on where this happens in the refinery, this could have effects on different process units, including the steam polishing systems in the boiler. It could become fouled. The heated boiler themselves could become fouled with the oil or hydrocarbons, which could cause corrosion or overheating of different parts of the steam boilers. And then if any of that fuel or hydrocarbons get into the cooling towers, those could be fouled in a very different way, but that could also cause hazardous area conditions. Leaks within heat exchangers can occur in many different formats. Many people think of them as happening catastrophically, meaning that a heat exchanger will burst and hydrocarbons or oils will get into the cooling or steam condensate loops immediately and continuously. But they can also be very small, therefore very hard to detect. For instance, if these heat exchangers heat up or cool down during a turnaround or during changes in process conditions, a very small crack in a weld on that heat exchanger could cause a small leak. When the process heats back up or changes temperature, those small cracks could disappear, stopping the leak. So these leaks could be very short-lived and therefore very difficult to detect. In this drawing, we're illustrating a typical desalter within an oil refinery. The crude oil before the desalter is heated by steam process to about 250 to 300 degrees Fahrenheit. The crude oil after the desalter, before the distillation, is further heated to 700 to 800 degrees Fahrenheit. If a leak were to occur in either of these places, our TD4100XDC with a SampleTHIEF could quite easily detect a leak within a few seconds of it occurring. The SampleTHIEF could collect a water sample, which would allow the operators to analyze a water sample and determine which part of the refinery the leak comes from. Our TD4100XDC is available for detecting leaks at very low concentrations before they become significant. The TD4100XDC is available with ATEX Zone 1 or Zone 2, Class 1 Div 1 or Class 1 Div 2 certification. If a general purpose monitor can be used, our TD120 is a good low-cost option for the same purpose. When an operator wants to know the type of hydrocarbons that are in the water, a SampleTHIEF can be used in conjunction with these two monitors. This will automatically collect a water sample when an oil alarm is actuated. Operators can collect the water sample, take it to a laboratory where it can be analyzed for the type of hydrocarbon to help identify the leak source. So overall, the solutions include ultraviolet fluorescence oil water monitors and a sample collection system. The benefit of ultraviolet fluorescence is that the response is immediate for quick detection. Sensitivity is very high for detection of leaks at very low concentrations before they become significant, with no moving parts, no reagents, and no chemicals needed for sample preparation. The reliability of fluorescence devices is very high. With a sample collection system, operators will know what type of hydrocarbons are in that water to identify the potential heat exchangers for the leak source. And hazardous area certification is available for both fluorescence instruments and the SampleTHIEF. If you have any further questions, please contact us through our webpage, www.oilandwatermonitors.com, by email at sales@oilandwatermonitors.com. Again, I'm Chip Westaby, Sales Manager for Benchmark Measurement Solutions, formerly Turner Design Hydrocarbon Instruments. Thank you.